Let's look at the impedance of a transistor. We shall start with the input impedance. This is the structure we shall use. We start with the NPN. This side we have our collector, our base, and our emitter. Collector current passes through a resistor, goes into the transistor, and then we have the base current passing through resistor, then into the transistor, and then goes out through the emitter. We have current IE passing through the resistor RE, and then this is our voltage source. Remember, since this arrow is pointing out, not pointing in, then that makes it NPN transistor. We shall call our input impedance Zin. Zin is equal to the derivative of input voltage divided by the derivative of input current. So in other words, that's the change in voltage that is going in, and the change divided by the change of current going in. The input voltage is the same as the base voltage, and it is equal to the summation of VBE and VE. Input voltage is the same as VBE, which is equal to VBE plus VE. And this is the same as VBE plus, from Ohm's law, IE RE. Then also remember that IE is equal to IB plus IC. And we found out that IC can be represented as beta IB, which is the same as beta plus 1 IB. But then the current passing through the resistor B is the same current that we shall call our input current. Therefore, and also the base current is the same as the input current. If we are to get this, put it here, and then we get our IE, replace it here. We have input voltage equal to VBE plus beta plus 1 input current times RE. Therefore, our Z input impedance will be given by derivative of V in, which is VBE plus beta plus 1 input current times RE, divided by the input current. Since beta is a big number, beta is far greater than 1, we can have our Z in input impedance as beta plus 1 RE approximating to beta RE. From this equation, emitter current is big due to the current gain. beta. Now that implies that the base current amplification makes RE to appear larger to a source.